So we come to the end of Module 3. We've been focusing on what I call computational fluency, looking at addition, subtraction, multiplication, and division, and thinking about how do we develop fluency. And I've alluded to what I mean by fluency along the way, but I wanted to end with the final formal definition of fluency that is often used in mathematics education. I'm going to have to read it to you. Check it out. Fluently includes engaging efficiently, accurately, flexibly, and appropriately. I want you to think about that for a minute. There's been so many cases, if you reflect back on addition, subtraction, multiplication, division, that the standard algorithm that you learned may not be the most flexible or efficient thing to do. Flexibility comes when students have a variety of ways and they will engage in the way that makes sense in that context. Students are able to choose flexibly among methods and strategies to solve contextual and mathematical problems. They understand and are able to explain their approaches, and they are able to produce accurate answers efficiently. And I want to emphasize that. Sometimes in my world, people will debate and say, well, all this stuff that you talk about, but what if they get the wrong answer? Well, that's not part of fluency then. We do want students to be accurate in their computations. Accuracy does matter, but it's developed. And in the development of it, it sometimes looks messy. And then we have to work, as I hope you've seen in this module, we have to work to clean it up and get students to be organized and efficient in their work. But efficiency, students can carry out easily. They can keep track of sub-problems and make use of intermediate results to solve the problems. Think about the multiplication algorithm. I used the area model. So the big picture was the multiplication product, but the sub-problems were all those sub-areas that had to be computed, and then the sum of all those that had to be computed. Accuracy kind of speaks for itself, but reliably produces the correct answer. Flexibility knows more than one approach and chooses a viable strategy and uses one method to solve and another method to double check, perhaps. I'm not saying that you always have to do it twice, but you could, is the point. You could. But also here, you've seen like with subtraction, it was easier to count on in the case of buying the furniture than it was to do the algorithm. And then appropriately means students know when to apply a particular procedure because of the experiences that they've had. All right, so I want you to reflect on, I know I said square root algorithm here, forget that for a minute, but reflect on all the experiences that you've had in this module. How is it that I've been promoting, emphasizing, encouraging? How is it that I've been encouraging the development of fluency in our students? And keep track and keep in mind that fluency involves these four things: efficiency, accuracy, flexibility, and appropriately. So I encourage you, pause the video right now and reflect on how has fluency been developed. All right, now I'm going to give you one more way. This is going to be an interesting, I hope, way that you can think about this. And then after I do this video quickly and set it up, you're going to go back to the Google slides. But it goes like this. I would like you to choose 2 digits from this list of numbers. I've given you 0 through 9, and I want you to choose 2 digits. Now, of course, you're not with me, so I have to then choose for you. You chose 8 and the 4. Just pretend. All right, now take the 8 and the 4, and with the 8 and the 4, you can actually make two two-digit numbers. You can make 84 and you can make 48. Now I'd like you to subtract those two numbers. 84 minus 48. And you can do that in multiple ways. Maybe a count-on strategy. Maybe it's maybe you're thinking 80 minus 50, and then you have to do 6. Think about a way that you can do this fluently, but whatever you think about, you should get 36. All right, then I say, hey, pick 2 more numbers. I don't know, somebody says 7 and 3. I did 8 and 4. Somebody says 7 and 3. All right, with 7 and 3, you can make 73, and you can make 37. Subtract those two numbers. Maybe in this case you go standard algorithm. You're going to you're going to exchange a 10 for 10 ones to make us have 13 ones. And 13 minus 7, that would be 6 ones. And then 6 tens minus 3 tens is, oh, you also get 36. That's interesting. I'm going to pause there. What I would like you to do, this video is going to end, but I need to trust you here. I want you to play with this for a few minutes, like several minutes. Pick two digits, form your two numbers, the larger one, the smaller one, subtract the smaller from the larger, and see what you get. Sure seems like it comes out 36. Does it always come out 36? All right, get out a piece of paper and play for a minute. Go.